All right, so section 8.2, we could potentially have a second day, but let's see what we can get through today. This is an abbreviated version of all of the things that we could do in this lesson. All right, so recall the graphs of sine and cosine. Okay, we have talked about these in the past. Remember the domain of all four of these things will remain the same for both trig functions. The domain is all real numbers. Okay, if we wanted to write that interval notation from negative infinity to infinity. Our range, we've spoken about this most recently when we've been solving trig functions. The range is from -1 to 1. Okay, so when we were solving, if a sine or cosine function equation was set equal to a number bigger than 1 or smaller than -1, there was no solution. The period, if you recall, the period is how long it takes for the graph to repeat itself. It's the length of one cycle. Okay, so if I trace from one defining point to another on both sine and cosine, the period, oh, my computer punks out there, is 2 pi. And your textbook will refer to that as the fundamental period. The amplitude is the height of the function. We'll talk about a little expression to be able to find it, but it's all based on what we call this midline here. And on sine and cosine, it would be really the height from the x-axis. So on both of these functions, in either direction, we go up 1 and down 1. So the amplitude is +1. Okay, so now when we start transforming sine and cosine curves, and you've looked at transformations of our parent functions. All right, so the only values we're going to deal with in this, like I said, it was abbreviated, are the values of A and B. Okay? A is the letter, or is the value that'll determine the amplitude. And like I said, here's your little expression. The highest y value minus the lowest y value divided by 2. A simpler term, the amplitude is the height, and the height always has to be positive. A can be any real number, positive or negative, but the amplitude has to be a positive value. The period, so the fundamental period is 2 pi. That's why we see this here. So to determine the period, if there's a value in front of the x, it's 2 pi divided by b. And again, the period, the cycle length of a curve, or how long the wave takes to repeat itself. The phase shift, the vertical shift, the axis of the wave, these are not, we're not going to study those this year just for time's sake, but that's the significance of the value of C and D. So when we did translations of our parent functions, remember that our vertical shift always stayed the same. Our horizontal movement was always the opposite of whatever was inside the parentheses. Okay, so part of what you're going to have to do is, given a periodic graph, you have to determine what the period is. So the goal for you, and I actually like this because it's not none of my scales in terms of pi, you have to focus yourself on one defining feature to another. So how long for the wave to repeat itself? So if I just pick one point, I could determine how long would it take for me to get from maximum to maximum. Okay, what's another one we could do? I could look at, all right, well, let me check out, what if I started at this point? Well, then how long would it take for me to get from that minimum point to another minimum point? That's another way I could determine the period. A third, okay, well, let me start here. How long would it take for me to trace this graph? So I start at the x-axis, and then I have to end at the x-axis. Now, I wouldn't end at this point because I haven't traced an entire cycle yet. Okay, so there's a bunch of different ways you could look. And then on the next slide, I'm going to highlight. So here's the graph again, and I highlighted those areas. So if I go from maximum to maximum, all right, then to determine the period, well, really, we're just finding the difference between those values. So period is always going to be positive. So I could do from one x value minus the other. Okay, -3 pi over 8 to pi over 8. Now, on your homework and on graphs, you're going to be able to see the scale. Okay, I put the points in because I understand you can't see those. So this would give me -4 pi over 8. So the period of my function is pi over 2. Likewise, I could do it as pi over 8 minus negative 3 pi over 8. And this would give me the positive value. So you guys would have seen this as distance on a number line when we just take the difference between two values. That's all we're doing here, okay? And if you think from 3 pi over 8 to 7 pi over 8, I've moved 4 pi over 8 units, so the period of this function is pi over 2. It takes pi over 2 units for this cycle to repeat itself. All right, now looking at equations, you need to be able to determine the period and the amplitude. So remember A, sine or cosine of B, and then times x plus c plus d. All we're concerned about are the values of A and B. Amplitude is A, the absolute value of that. So for number 1, my amplitude would be 2, and my period would be 2 pi over 3. Well, where did those things come from? Because my value of A is 2, because A is the first coefficient. It's the coefficient to the trig function. My value of B is 3. Where does B come from? It's the number in front of the x, okay? So number 2, my A value is negative 4. My B value here, don't let this confuse you, please. Dividing by 5 is the same as multiplying by 1/5. If B was going to be equal to 5, then the equation would look like this, cosine of 5x. Okay, so dividing by 5 is the same as multiplying by 1/5. All right, so my amplitude, absolute value of negative 4 is positive 4. The period, 2 pi divided by 1/5. Okay, let's not forget all the math we've studied. Dividing by 1/5 is multiplying by its reciprocal, which is just 5. So the period is 10 pi. Okay, so if you think about this, it's going to stretch the graph out. So if my cosine graph was from 0 to 2 pi, was the original period, well then it's going to take all the way until 10 pi to stretch this graph out. So we're not, again, because of the situation, we're not going to be looking at graphing. But that's what that means, okay? It's stretching out the function. It's going to take a lot longer to graph what that parent function would look like. As opposed to this guy, so if this is from 0 to 2 pi, my cosine is my parent graph. Well, 2 pi over 3 is a second quadrant angle, so it's going to be even before pi here. So what that means is I got to squeeze this graph into this tiny little space. Okay, so stretching and shrinking the period. All right, same deal. So here A, when there's no number written in front of the sine or cosine function, we know it to be 1. B is just the number in front of the parentheses, so B is 8. And I added in some phase shifts because you're going to see that in the classwork, even though I'm not going to ask you to determine it. So my amplitude is just 1. Period. Fundamental period is 2 pi. I divide that by the value of B. So that would give me pi over 4. And that's all we want you to do. Okay, A here is 1/6. B is the number x is being multiplied by. So in this case, B is in terms of pi. That's okay. All right, my amplitude is 1/6. And the period is 2 pi divided by pi over 3. Okay, so I take 2 pi, I multiply, hold on, honey. Okay, so in this case, the pi's cancel each other out, and the period is going to be 6. It's a scalar value. So if we were to graph it, then our x-axis would be not in terms of pi anymore, but it would be more like we're used to with just scalar values, okay? But the period would be 6. That's okay. All right, that is allowed. You don't have to have pi in the answer. All right, we have a few more minutes. Let's check out solving. I don't know how much we're going to get to for here, but let's check it out. Okay, you spent a whole lot of time solving. If I gave you cosine of x is equal to root 2 over 2. Couple things from the homework. 1, not reading directions. My angle measures have to be radian values. Okay, square root of 2 over 2 is a value from my exact value chart. Its reference angle is pi over 4. Cosine is positive in quadrant 1 and quadrant 4, so that would be my answer if I was just solving cosine of x. But check out what's happening here. We're changing the period of the function, okay, because x is being multiplied by a value. So what that does is it affects the answers that we have. So one thing that your textbook does, which I like, 0 is less than or equal to, which is less than 2 pi. Okay, well now my x is being multiplied by 2. So if I multiply my x by 2, I got to multiply everything by 2. So now, in order to get all the values that satisfy this function, cosine of 2x, I have to look all the way to 4 pi. I have to take 2 rotations around the unit circle. Okay, that's what the value of b represents. It represents how many times am I rotating around the unit circle. So how does that change our answer? Well, we're going to have twice as many. So now I still keep my same reference angle, but 2x is going to be equal to pi over 4 and 7 pi over 4. That's one rotation around the unit circle. Now I got to take another rotation around the unit circle. So I'm going to have pi over 4, and I'm going to add 2 pi to it. Why 2 pi? Because that's one rotation around the unit circle. So 4 times 2 is 8. So this gives me 9 pi over 4. And then I'm going to take 7 pi over 4, and I'm going to add 2 pi to that. And I get 15 pi over 4. Okay, but the goal is to solve for x. So even though that 2 told me that I have to rotate around the unit circle 2 times, which means I have 2 quadrant 1 angles and 2 quadrant 4 angles, my final step is going to be to divide by 2 to solve for x. Dividing each of these by 2 is really multiplying each one by a half. Okay, so when I finally solve for x, don't forget that's the ultimate goal. I get pi over 8, 7 pi over 8, 9 pi over 8, and then 15 pi over 8. So there's twice as many solutions that we're used to. And these pi over 8, a denominator of 8, we're not familiar with either. But if we're changing the period, then where these values occur are going to look a little bit different. So these are my complete 4 solutions. And all of my answers need to be less than 2 pi. And I know that 16 pi over 8 is equivalent to 2 pi. So all my values, that 15 pi over 8 is just below that. Okay, the problems you're responsible for will be assigned separately. That'll do it for this video.